Section 1. Newton's Wild Ride, a hilarious introduction to motion. Picture this, a young Isaac Newton sitting under an apple tree, minding his own business. Suddenly an apple falls on his head. Ouch! But instead of getting angry, he gets curious. Why did the apple fall? These questions led to some of the most important discoveries in physics. Motion is everywhere. It's in the way you walk to school, the way your dog wags its tail, and even in the way the Earth spins around the sun. So buckle up, science enthusiasts. We're about to embark on a roller coaster ride through the laws of motion. Section 2. The Three Amigos of Physics. Meet Newton's laws. Ladies and gentlemen, boys and girls, allow me to introduce you to the stars of our show, Newton's three laws of motion. First up, we have the law of inertia, also known as the lazy law. This law is all about objects being stubborn. Next in line is the law of force and acceleration. It's all about how force, mass, and acceleration are related. Last but not least, we have the law of action and reaction. For every action, there's an equal and opposite reaction. These three laws work together to explain pretty much everything that moves in our universe. From the tiniest atom to the biggest galaxy, these laws have got it covered. They're like the Swiss Army knife of physics. So let's dive into each one and see how they make the universe tick. Ready? Let's go. Section 3. Law number 1. The lazy object's guide to motion. This law states that an object at rest stays at rest, and an object in motion stays in motion, unless acted on by an outside force. Think about it this way. Imagine you're sitting on the couch watching your favorite science show. According to the first law, you'll stay that way forever. Or at least until your mom yells at you to take out the trash. Now let's flip the script. Imagine you're riding your bike down a hill. According to the first law, you should keep going forever, right? Well, not quite. There are outside forces at work here too. Things like friction from the road, air resistance, and eventually, that big tree at the bottom of the hill. This law explains why we need seatbelts in cars. When the car stops suddenly, your body wants to keep moving forward. The seatbelt is the outside force that stops you from flying through the windshield. So next time your mom tells you to buckle up, you can say, "Don't worry, Mom, I'm just obeying Newton's first law of motion." Section 4. Law number 2. Force and mass, a weighty affair. This law is all about force, mass, and acceleration. It states that the acceleration of an object depends on two things, the force acting on it and its mass. In mathematical terms, it's written as F equals ma, where F is force, m is mass, and a is acceleration. Imagine you're pushing a shopping cart. If the cart is empty, it's pretty easy to push, right? You can get it moving quickly. But what happens when you fill that cart with a mountain of groceries? Suddenly it feels like you're trying to push a baby elephant. The force you're applying is the same, but the mass has increased, so the acceleration decreases. Now let's flip it around. What if you kept the mass the same, but increased the force? With more force applied, the acceleration increases. This law explains why it's easier to push a tennis ball than a bowling ball. The force you apply might be the same, but the mass of the bowling ball is much greater, so it accelerates less. So next time you're stuck behind a slow-moving truck, just say, "Ah, Newton's second law in action." Section 5, Law number 3, the cosmic dance of action and reaction. This law states that for every action, there is an equal and opposite reaction. Let's start with a simple example. When you jump, you're not just pushing yourself up into the air. You're actually pushing the Earth down. This law is also what makes rockets work. The rocket engine pushes hot gases downward with a huge force. In response, those gases push the rocket upward with an equal force. The same principle applies when you're swimming. You push water backwards and the water pushes you forward. But here's where it gets really fun. This law doesn't just apply to physical objects, it works for everything. When you smile at someone, they often smile back. When you're nice to others, they're usually nice in return. It's like Newton's third law of motion applies to kindness too. So go ahead, spread some positive actions and watch as the universe reacts with equal positivity. Who knew physics could be so heartwarming? Section 6, moving forward. The punchline of physics. Well folks, we've reached the end of our whirlwind tour through Newton's laws of motion. We've learned that objects are lazy and resist change, that force and mass are in a complicated relationship, and that the universe is constantly playing a game of tag, you're it. Understanding these laws isn't just about acing your physics test, it's about understanding the world around us. So the next time you're pushing a shopping cart, jumping into a pool, or just walking down the street, take a moment to appreciate the complex physics at work. And remember, stay curious, stay playful, and keep moving forward.